Hello everyone, this is Varsha Shetty dealing with mathematics subject. Okay, so now in that the chapter is understanding quadrilaterals. So I am here to deal with the chapter number 3, understanding quadrilaterals, grade 8. Okay, so that is grade 8. Students, when you look to the chapter name, that is understanding quadrilaterals, you are all familiar with the name here. Okay, I can tell that understanding is a familiar word for you. Okay, and quadrilateral, you must know what is this quadrilateral. The word understanding seems very easy. Yes, what we are doing, we are going to analyze, we are going to understand something about what? About the quadrilateral. So here, before going to the definition of quadrilateral, we must study some of the terminologies here. Okay, so the terminologies, whatever I have written, you can see here. The first one is the polygon, and the second one is classification of polygons. Next, diagonal. Next, convex and concave polygons, regular and irregular polygons, as well as angle sum property of a polygon. You also have to study the exterior angle sum property of a polygon, so which we will study after the last one, that is angle sum property of a polygon. So one by one we will see first. So that is, first we need to study what is polygon. Yeah. So before going to the definition of polygon, I want to explain you the basic things. That is, I'll just put a tip of the pen on board. So what can you see here? This is a point. You directly call it as a point. So what is a point? Point is just when I give a tip of pen, paper, whatever I am using, this is the plane. Here might be your paper, might be the board. So this I can tell it as the point. Point. Next comes what? Next is a line. What is a line? So line is just a line, so which can be extended endlessly on both the sides. So line has no end. Line has got no ends. It can be extended to the infinite number of times to both the ends. That is, we define it as a line. Next comes is line segment. Next comes is line segment. So I can define this line segment as, a part of line which has two endpoints and which can be measured. So this line segment is a part of line. I'm taking some part of the line, so which has the endpoints, and it can also be measured, whereas line cannot be measured. Okay, and next is ray. A ray has one end point or the starting point, and also I can tell ray can be extended to infinite number of times only in one direction. It also has only one, you can tell it as end point or the starting point. This is ray. So why I am explaining all these things is related to the definition of polygon. So what I do is, I'll just take a point and two rays are emerging from this point. Two rays are emerging from this particular point. So what can you see here? There is some space here. There is some space. Yes. So what is this? There forms a space. I'll just mark it like this. What is, you call it as an angle. So this is an angle. Okay. So how many line segments or rays I have used? I have used only the two line segments. Okay. Can you tell me whether this particular diagram, whatever I have drawn, is the closed one or the open one? I have just taken like this. It was like this. It was open. Okay, it was open. So do keep in mind, this is open. Now let us go back. So this is all the recapitulation of your 7th standard, whatever you have studied in your lines and angles chapter. So which is also related to the extended part of the chapter, that is understanding quadrilaterals in your 8th standard. Okay, so now to the actual definition of polygon. Let's see the actual definition of polygon. Polygon is a simple closed curve Yeah. So you can see the definition I have written on board. That is the definition of polygon. Polygon is a simple closed curve made up of only line segments. So what is a polygon? It is a simple closed curve. It should be a simple closed curve. We'll just draw something. See, it is a simple closed curve. It is not open. Whereas when we have drawn the angles there, so it was just a open figure. It also had the line segments. Okay, it also had the line segments. But you can see this particular figure as the closed one. So it is a simple made up of only line segments. You can see only the line segments. Okay, you can see only the line segments. Such particular figures, you call them as a polygon. Not only this one, polygon may be a triangle, polygon can be a pentagon. This is a polygon. This is also a polygon. This is also a polygon. So children, you need to keep in mind the two words in this particular definition. That is, it is a simple closed curve. So this particular word, closed curve, and made up of only line segments. These two are very important. So if you miss any of the word among these two, so this particular definition becomes incomplete. Okay, you cannot properly define a polygon without these two words. So these are very important. Rather than telling us important, I can tell these are the terminologies, the important terminologies in this particular definition. Okay, polygon is a simple closed curve made up of only line segments. Let me ask you a question. Yeah. So can you tell this as a simple and simple closed curve? Is this closed? Yes, of course, this one is closed. Also, this is a simple closed curve. But what is the difference between these three figures I have drawn and this one? Look into the definition, what I have told. The word line segments made up of only line segments is very important. Okay, so but can you see any line segments in this particular figure? No, you will call this as a circle. This one is a circle. You cannot see any of the line segments. So I can tell this as the simple closed curve, but not as a polygon. Do keep in mind, this is a simple closed curve, but not a polygon. Why? Because the condition for polygon is not satisfied for this particular figure. Which is the condition? It should be made up of only line segments, but you cannot see any of the line segments here. So therefore, this cannot be called as a polygon, but it is a simple closed curve. Okay, so let me draw one more. So what do you call this? This is also a simple curve. Simple open curve, I can tell. This time. If I just draw like this is a simple curve. What type of a curve is it? This is simple open curve. This is not closed. So therefore, this is simple open curve. Okay. So I hope you better understand the differentiation between the simple curve, simple closed curve, and a polygon. Okay. So circle cannot be the polygon. Why? Because it is not made up of any line segments. You cannot see any line segments in circle. Okay. We say that circle has in fact a polygon. Okay, children. Yeah, so this was about the first terminology, polygon. Now let's see classification of polygons. So how the polygons have been classified? So let me tell you, the polygons have been classified based on the number of sides or based on the number of vertices, I can tell. These polygons have been classified based on the number of sides or number of. Let us see. Second one is classification of polygons. Yes, children, I told you polygons have been classified based on the number of sides or number of vertices. Yeah. So polygons have been classified based on the number of sides or number of vertices. I have just drawn in the definition of polygon. I have just drawn a figure. So this was what I have drawn. Okay, and also I have drawn this one. Okay, so let me make the columns. That is number of vertices or sides. Number of vertices or sides would be one column. Okay, so this was the example what I was showing. So we have the number of sides or vertices. Next is name of that particular polygon. Name of the polygon and a simple figure. And a simple figure. Yeah. So as I told you that polygons have been classified based on the number of vertices or sides. So initially I have shown you. Let us take two vertices. Vertices is nothing but the vertices is a plural form of vertex. Vertex is nothing but a point. If I just take 2 points and join them, either you join in this way or you join in this way. So what does it form? Does it form a polygon? Polygon. I say these two are not the polygons. Why? Because I have used, you can see, I have used two particular vertices in each case, but I cannot find a closed curve, simple closed curve. Yes. So why I am telling this is, let me come to the point. So I'll use number of vertices be 3. Number of vertices be 3. So if there are 3 vertices, what do you call such a figure? You call it as a triangle. You call it as a triangle. And how does it look? See, there are 3 points. I can say 3 non-collinear points. Okay, 3 non-collinear points. So if I just join them, it forms a polygon. If I just join them, it forms a polygon. Okay, so how do you name this as? We already named it as a triangle. Triangle is a simple closed curve made up of 3 line segments. Triangle is made up of 3 line segments. Rather than telling it again and again as a simple closed curve, I can tell it as it is a polygon. Triangle is a polygon with 3 line segments or else with 3 vertices. Okay, students, I hope this is clear. That is, triangle is a polygon with 3. Next, if the number of vertices are 4, what happens? If the number of vertices are 4, let us name that later, but let's see what happens. If the number of vertices are 4, any random 4 vertices. Yeah. If the number of vertices are 4, What do you call this as? I call this as a quadrilateral. Quadrilateral. Why it is named as a quadrilateral? So quadri means four, lateral sides. Four-sided figure is called as a quadrilateral, and I can tell quadrilateral is a polygon with the four sides. Quadrilateral is a polygon with the four sides. Okay. So next, continuously we'll see with the number of sides. That is, when the number of sides are 5, so it can be a pentagon. Let me first draw it. Okay, so if the number of sides are 5, we'll see. I'll show it here. Continue that part. We have seen with the 3 vertices. Also, we have seen with the 4 sides of vertices. Now let's see with the 5 vertices. Number of vertices. Name of polygon. And the simple figure, how it looks. Okay, so name of vertices, number of polygons, and let us see the example for that particular polygon. So if the number of vertices, if I take it as 5, the number of vertices are 5, I call it as a pentagon. Pentagon, and the pentagon looks this is the pentagon. You can see vertex number 1, 2, 3, 4, and 5. If you count the vertices are also 5, and if you count the sides are also 5. Therefore, I call it as a pentagon. Okay. Next, if the number of vertices are 6, I call it as a hexagon. Hexagon. So let me draw the hexagon. See, this is a hexagon with the 6 sides or with the 6 vertices. Vertex number 1, 2, 3, 4, 5, and 6. Even if you count the sides are also 6. That is side number 1, 2, 3, 4, 5, and 6. So a polygon with the 6 sides would be a hexagon. Next, a polygon with the 7 sides is heptagon. Heptagon, or else you can also name it as septagon. Heptagon or septagon. So a polygon with 7 sides is named as heptagon or septagon. So let me draw a polygon with 7 sides. Yeah, this is a rough figure, whatever I have drawn. You can check the number of vertices. 1, 2, 3, 4, 5, 6, and 7. Number of vertices, if you check, those are also 7. And number of line segments, if you check, see, line segment 1, 2, 3, 4, 5, 6, and 7. 3, 4, 5, 6, 7. There are 7 vertices, also there are 7 line segments, or else 7 sides. A polygon with 7 sides is named as heptagon or septagon. Similarly, a polygon with 8 sides, we call it as octagon. You can extend the number of sides and you can draw a figure like, say, 1, 2. This is an octagon. 1, 2. Count the number of vertices. 1, 2, 3, 4, 5, 6, 7, and 8. It has 8 vertices, also 8 sides. Similarly, a polygon with 9 sides would be nonagon. Nonagon. So the pronunciation for you would be easy to pronounce it as nanogon. You have got a car by name Nano. but it is not nanogon, it would be nonagon. Okay, and a polygon with 10 sides is decagon. A polygon with 10 sides is decagon. Similarly, a polygon with 10 sides is decagon. Similarly, I can also draw the figures here. So nonagon would be, you can just extend the number of sides. That is 1, 2, 3, 4, 5, 6, 7. Yeah. So this is a rough figure where you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Children, similarly, you can also draw a decagon. What have you observed after this septagon or heptagon? What have you observed? Observe the figures. This one and the octagon, also nonagon. Even if you draw the decagon, what happens? As the number of sides are increasing, the figure is becoming more like a circular one. Yes or no? The figure is becoming more like a circular one. So you can still draw it properly. This one is nonagon. Decagon also if you draw. What I mean to tell is, as the number of sides increases, so the figure at some point, at some number of sides, the figure becomes a circle. So we don't know the number of sides. We say that circle has infinite number of sides. So these are the polygons, classification of polygons based on the number of sides or vertices. I hope it is clear. 10, what next? After 10, what next? How do you name them? It was 5, 6, 7, 8, 9, 10. We have reached to the 10th vertices, a polygon made of 10 vertices, which was decagon. Next. Similarly, if I just put on a dash in between, if I have n sides, or n vertices, so what do you call that particular polygon as? You call it as n-gon. And based on that number of sides, you can draw the simple example for that particular polygon. So do keep in mind, polygon is a simple closed curve made up of only the line segments. That is very important, and this is what the classification of polygons. So you must know the definition clearly. Why I am telling again and again is the definition of polygon is very important in this chapter, understanding quadrilaterals. So as we see understanding quadrilaterals, these are the classification of polygons, but completely in this chapter we are going to deal with only the quadrilaterals. So after this, so let's see what is a So, as you all know, diagonal is a familiar word for you. You also know how to draw a diagonal to a particular given polygon. Okay. So, let me take a quadrilateral. Okay. This is a quadrilateral. So, how do I draw the diagonal? I draw the, let me name this as A, B, C, and D. A quadrilateral with the 4 sides. I have named it as A, B, C, D. So I'll draw the diagonal from A to C and also from B to D. Okay. You can observe I have drawn the diagonal from A to C and from B to D. So I call this as a diagonal. But what is the proper definition for a diagonal? So let me define it. Diagonal is a line segment. Diagonal is a line segment connecting two non-consecutive vertices of a polygon. Do keep in mind, diagonal is a line segment connecting two non-consecutive vertices of a polygon. So what is the meaning of non-consecutive vertices? Which are not very next to each other. I cannot draw a diagonal from A to B. This part I cannot draw this particular point. Point A is directly joining to very next point, which is B. Okay, so I can say point B is collinear with the point A. So condition for a diagonal should be, a line segment should join non-consecutive vertices, any two non-consecutive vertices of a polygon. Therefore, the diagonals of ABCD. So ABCD is what? This is our quadrilateral. Okay. So the diagonals of ABCD are, what are the diagonals? One is AC and the other is BD or DB. Okay. So these are the diagonals. Not only for this, you can also draw the diagonal for the types of polygons what I have explained just before. Okay. So the types of polygons we have studied. This was about the quadrilateral. Okay. We also had a pentagon, hexagon, heptagon, octagon, nonagon, decagon, and n-gon. Okay, to all the types of polygons, you can draw the diagonals, but do keep in mind, diagonal is a two non-consecutive vertices of a polygon. For example, let me show one more example. So I'm just drawing the figure on board. You can analyze what is the name of this polygon. You can see, you can check the number of vertices 1, 2, 3, 4, and 5. There are 5 vertices. What do you call this as? This is a pentagon. Pentagon. Okay. How do I draw the diagonals for this? So let me name this as well as A, B, C, D, I, E. Okay. So the diagonal is a line segment connecting two non-consecutive vertices. The first diagonal would be from A. Let me start from A. I'll draw from A to D is one diagonal and A to C is another. Next, from E to B is the third diagonal. This is the fourth one. And from E to C or from C to E is the fifth diagonal. Okay, so how many diagonals does it has? It has 5 diagonals. If you miss anything, so I think you are familiar how to draw the diagonals now. A to C as well as from B to E or from E to B. Okay, so we have drawn the number of diagonals. Children, I want to tell you the formula to find out number of diagonals in a particular polygon. Okay, when it comes to till decagon, or else still if you have the number of sides of a polygon with 20 sides, that would be easier. Okay, for example, let us show 100-sided polygon. So I have a polygon with 100 sides. So how will you draw that particular polygon and how will you draw the diagonal from each vertex to every vertex? Okay, so is that possible? Yes, but it is possible. But in this present era, nobody has got that much of time and patience, right? So for that purpose, think what should be done. So I will give you a formula for this. That is, formula to find out number of diagonals in any given polygon would be n times n minus 3 divided by 2. N times n minus 3 divided by 2 would be the formula to find out the number of diagonals, where n stands for number of sides. N stands for number of sides or number of vertices. Anything would be fine. Okay. So to find out the number of diagonals in a particular given polygon, the formula would be n times n minus 3 divided by 2. So using this particular, for pentagon also, I can verify this formula. Let us verify. Wherein you have 5 sides. So how many diagonals did we draw? 1, 2, 3, 4, and 5. 5 diagonals we have drawn. Let us check whether using this formula we are going to get 5 diagonals or not. For example, in this particular, n is equal to 5 for a pentagon. So 5 times, just substitute in this formula, 5 minus 3 divided by 2. So 5 times 5 minus 3 is how much? That is 2 divided by 2. So let me write it aside. So if we just take it here, so this is 5 times 5 minus 3 is 2 divided by 2. Okay, 2 and 2 gets cancelled. That is 2 ones are 2 and 2 ones are 2. So left is what? 5. What is that 5? So what formula did we? The formula to find out number of diagonals in any given polygon. So this you can also sit and draw, or else you can go for the formula n times n minus 3 divided by 2. Yes, the concept of diagonal would be clear, I hope. But let me ask a question. What about the diagonals of a triangle? What happens? So how many diagonals can you draw to a triangle? As I told, let us see for a triangle. Let's see. Let me draw a triangle first. And name it as ABC. How many vertices it has? As you all know, it has 3 vertices. Okay. So now tell me, can you find any non-consecutive vertices here? A is joining to B, and from B, if you start your journey, you are going to C. Okay, so I cannot find the non-consecutive vertices here. So therefore, what about the number of diagonals? What about the number of diagonals for a triangle? So the number of diagonals for a triangle would be 0. I cannot draw any diagonals. Why? Because it doesn't have any non-consecutive vertices. Also, if you take the formula n times n minus 3 divided by 2, wherein n is equal to 3 for a triangle, 3 vertices or as 3 sides if you take, so that would be, substitute the value of n in this particular formula, 3 times 3 minus 3 divided by 2. Okay, so 3 times 3 minus 3 would be 0 divided by 2. What happens? 3 multiplied by 0. 3 into 0. That is, let me write it here, the continuation part. So that is 3 times 3 minus 3 would be 0 divided by 0. So 3 multiplied by 0 is 0, or else we also say any number multiplied by 0 would be 0. That is 0 divided by 2, which you have already studied in your rational numbers. The denominator cannot be 0. Yes, we don't have a 0 here. So 0 divided by 2 would be 0. So what did we find the answer for? The 0 is, we were finding the number of diagonals, and we found the 0 diagonals in a triangle. Okay, so triangle does not have any diagonals. So this is all about. Next, coming to convex and concave polygons. Okay, so let us see what are these convex and concave polygons. Let me explain it one by one. First, let's see convex polygon. So we have already done with polygon, classification of polygon and diagonal. Okay, so these 3 things are completed. Coming to convex and concave polygons. First is convex polygon. Yeah, so you already know the definition of polygon. Now, what is a convex polygon? I will tell you. Convex polygon is a polygon which has no portion of diagonals in its exterior. Till now, we have drawn several polygons, several number of polygons. That is, triangle was a polygon, quadrilateral was a polygon, pentagon was a polygon. Yes, children, these we have already seen this. So I have also drawn the diagonals, and even triangle does not have any diagonal. That's okay. But if I draw the diagonals for a quadrilateral, can you see that it's the diagonals? Yeah. So I'll just draw something here. Yeah. So I tell that whatever I have drawn, this is the exterior of the polygon. This is the exterior of the polygon, wherein this is the interior of the polygon. For all these three, it remains the same. Okay, exterior part and the interior part, exterior part, interior, exterior and interior. For these two, Liobo triangle, why? Because we have already studied that triangle does not have any diagonals. Okay, for these two, if you see the diagonals, here are two diagonals, and also here are 5 diagonals. In these two figures, if you observe, can you find any of the diagonals outside the polygon or in the exterior of the polygon? No. Two diagonals are within the polygon, in the interior of the polygon. Here also, in this particular pentagon, all the 5 diagonals are inside the polygon. None of the diagonals are lying outside the polygon, or diagonals can be drawn in their exterior portion. Or else I can say a convex polygon is a polygon which does not have any portion of diagonal in their exterior. Also, all the angles in a convex polygons are less than 180 degree. Do keep in mind, 2 points you have to keep in mind. One is for the diagonals. The diagonals does not lie in the exterior of the polygon. All the diagonals are within the polygon. And one more thing about the angles is, all the angles measure less than 180 degree in convex polygons. Now let's see about the concave polygons. Yeah, the concave polygons. So we have seen the convex polygons. Coming to the concave polygons, concave polygon is a polygon which has a portion of diagonal in its exterior. So let me draw a diagonal polygon. Okay, these two are the polygons. You can find the difference here. You can look at this convex concave polygons. You can find the difference. What is the difference? Let us first count the number of vertices. 1, 2, 3, and 4. 1, 2, 3, 4, and 5. This was a quadrilateral. Yes, this is also a quadrilateral with 4 sides. This was a pentagon. This is also a pentagon. But what is the difference? I can call this as a convex pentagon, but this as a concave pentagon. Why it is concave? Let me define. A concave polygon is a polygon which has a portion of diagonal in its exterior. Let me draw the exterior. Or simply also you can assume without the exterior. Let me draw the diagonals for this. See, I'll show you the portion of diagonal in the exterior. The diagonal can be drawn here. See, this was the portion of diagonal. The red dotted line indicates diagonal for a concave polygon. Also, any one angle, at least one angle is more than 180 degree in concave polygons. At least one angle measures more than 180 degree in concave polygons, whereas all the angles in a convex polygons are less than 180 degree. So which is the angle? You can see this was 180 degree. Also, this is. Okay. So this is about the convex and concave polygons. Okay. So I hope the differences are clear. So this is, I will write it as concave quadrilateral, and this as a concave pentagon. So there is a difference between convex and concave polygons, but for your study, for this 8th academic, we are only dealing with the convex polygons. So we are only dealing with the convex polygons, but you must also know the concave polygons. Okay, so we have so this point is done. That is convex and concave polygons. Next is regular and irregular polygons. So these are all, again we are studying polygon, polygon and polygon. So now what is a regular polygon and what is an irregular polygon? Let's see. I can tell regular and irregular. A regular polygon is a polygon which is both equilateral and equiangular. A regular polygon is a polygon which is both equilateral and equiangular. So how is that? Let's say, for example, if you consider a quadrilateral called square. Oh, this is a square. So you already know all the sides of a square are equal in length. So let me note it like this. All the sides of a square are equal in length. Also, all the angles of a square measure 90 degree. All the angles of a square measure 90 degree. So I defined two terminologies in the definition, which was equilateral and equiangular. Yeah. So what do you mean? Lateral sides, equal sides. That means all the sides in a given polygon should be equal in length. Also equiangular. All the angles of a given polygon should measure equally. Okay. So therefore, a regular polygon can be defined as a polygon which is both equilateral and equiangular. So I can say square is a regular polygon. This is a regular polygon. Also, the example for regular polygon could be an equilateral triangle. In an equilateral triangle, you have all the three sides equal in measure, equal in length. Also, three angles equal in measure. So, an equilateral triangle is also, this is a square. Also, equilateral triangle. Equilateral triangle. For a square is also quadrilateral. Okay, I can name it as a regular quadrilateral. For that regular quadrilateral, you have got a specific name called square. But for triangle also got a specific name called equilateral triangle. But when we go with the number of sides, that is what I mean to tell is pentagon and hexagon. We just name them as a regular pentagon and a regular hexagon. We don't have a specific name for that. But yeah, now this is about the regular polygon. What about the irregular polygon? If any of these two conditions is not satisfied, any one condition among these is not satisfied, such a polygon we call it as an irregular polygon. If any one condition among these, let me give a best example for that. Irregular polygon. The best example for irregular polygon would be, you can name on board, if you can see, you can name what is this. It is a rectangle. So what happens in a rectangle? These two sides, that is the opposite sides, are equal in length. Yeah, if I these two sides are equal and these two sides are equal. And what about the angles? All the angles are equal in measure. That is, each angle of a rectangle measures 90 degree as that of a square. Okay, but what about the sides? We cannot. The condition in a rectangle, that is equiangular condition, is satisfied. But what about this equilateral condition? Yes. Rectangle is a polygon which is equiangular, but it is not equilateral. Therefore, I cannot call rectangle as a regular polygon. Rather, it comes under irregular polygon. So just keep in mind, polygon which is both equilateral and equiangular. In your language, if you want to understand, it should have equal length. All the lengths should be equal, and also it should have all the angles which are equal in measure. That's it. So that is about the regular and irregular polygons. The last point, that is angle sum property of a polygon. So angle sum property of a polygon, you are already familiar with the angle sum property of a triangle. Why? Because in the 7th standard you have already proved angle sum property of a triangle. So what is the angle sum property of a triangle? Angle sum property of a polygon. Yeah. So now we are studying angle sum property of a polygon. The angle sum property, angle sum of a triangle. Angle sum of triangle is 180 degree. This has been already proved. Now let us study. I have generally written it as the polygon. Angle sum property of a polygon. What is the angle sum of any polygon? We already know about the angle sum of the triangle is 180 degree. What is the angle sum of quadrilateral? What is the angle sum of pentagon, hexagon, and so on with the n-gon? Okay. So now let us see. To prove this property, I say that angle sum property of a quadrilateral is 360 degree. Let me write it. Angle sum property, angle sum of quadrilateral. It is 360 degree. So how is that 360 degree? Let us see now. Let me take a quadrilateral. I've taken a quadrilateral with the 4 sides or 4 vertices. Let B, C, and D. So children, I can tell you that each quadrilateral can be divided into 2 triangles. That is by drawing a diagonal. Okay. So that is, let's just draw a diagonal from A to C. So this would be triangle 1 and this would be triangle 2. So a quadrilateral can be divided into 2 triangles. So why I am connecting this with the triangles is already you know the angle sum of a triangle is 180 degree. So let me name the angles here. So this would be angle 1, angle 2, angle 3, angle 4, angle 5, and angle 6. I hope it is clear. Angle 1, angle 2, 3, 4, 5, and 6. So now, how to prove the angle sum of a quadrilateral is 360 degree? So as I have divided the given quadrilateral into 2 triangles, okay. So triangle then if I take, what is our triangle then? Triangle then is ABC. Let me write in triangle ABC. In triangle ABC, that is ABC. So what is the angle sum? That is angle 4 plus angle 5 plus angle 6 is measures how many degrees? 180 degree. So, angle sum property of triangle, call it as equation 1. Okay. So next, consider the second triangle, which is ABC or ACD. Next, in triangle ACD. So ACD if you consider, so or else ADC if you consider, better consider it as ADC or ACD. So angle 1 plus angle 2 plus angle 3 would be equal to 180 degree, again by the property of angle sum property of a triangle. So now after this, adding equation 1 and 2, what happens? Adding equations 1 and 2. If you just add, what happens? So equation 1 would be, that is, equation 1 would be 4 plus 5 plus 6. Equation 2 is 1 plus 2 plus 3. See, we have added the LHS part of both the equations and also add the RHS part of both the equations, which would be in RHS it is 180 plus 180. Okay, so angle 4 and 5. If you just 4, where are 3 and 4? I'll just mark with the blue ink. Angle 4 plus angle 3. These two angles make what? This is C, angle C. Okay, and angle 1 and angle 6. If you see angle 1 and angle 6, so this is what? So this would be angle A. So plus left is what? Angle 5, which is angle B. And also you are left with angle 4. So angle 4. I'm sorry, this would be angle 4 plus 3. So that is we got angle C, and also angle A would be angle 1 plus 6, and angle D would be angle 2. Yeah, here you can see you are left with angle 2, which is angle D, which is equal to, in the LHS part, sorry, in the RHS part, what did you have? 180 plus 180 was 360 degree. Okay, so you have angle C, angle A, angle B, and angle D. If you just rearrange accordingly alphabetically, that is angle A plus angle B plus angle C plus angle D. If I just add, so that would be how much? 360 degree. So what are these angles? 4 angles of a quadrilateral, which will sum up to 360 degree. So still the further part, that is the angle sum property of pentagon, hexagon, till to the n-gon, we will see in the next part. So for today, so these many points. So we'll continue in the next part. Thank you.